Types of matrices. Number one type is the one we call the row matrix. As the name implies, only one row. Example, we have A equal to matrix of 2, 5, 6. Only one row. It can have any number of columns. Like the dimension now, or the order is one row, 1. By how many columns? 1, 2, 3, 1 by 3. Another type is the column matrix. Column matrix. As the name implies, only one column. For example, I have B equal to matrix of A, B, C. This has only one column. But the number of order can be as many, the number of row can be as many rows as possible. But our main concern, it has only one column. That's why it's called column matrix. Like the order of this one now is 3 by 1. 1, 2, 3. So this is a column matrix. Then the next type is what we call a square matrix. Square matrix. As the name implies, square. This is a type of matrix that the number of rows equal to number of columns. For example, if I have A equal to matrix of 1, 2, 3, 4, you can see it has how many rows? 1, 2 rows. How many columns? 1, 2. So this is what we call 2 by 2 square matrix. I can have B equal to matrix of A, B, C, D, E, F, G, H, I. How many rows? 1, 2, 3. 3 rows. How many columns? 1, 2, 3. 3 columns. So this is 3 by 3 square matrix. Okay. We have another type of matrix, number 4. We call the null or zero matrix. 0. So this is a type of matrix that all the elements are 0. Example, I have A equal to matrix of 0, 0, 0, 0, 0, 0. All the elements are 0. So I can also have this matrix 0, 0, 0, 0, 0, 0, 0, 0, 0. All the elements are 0, irrespective of the dimension. We call it 0 or null matrix. Now, we have the number 5, which we call the diagonal. The diagonal matrix. Just as the name implies, this is a type of matrix that the elements in the principal diagonal are non-zero. They are non-zero. But elements in other sides are all zeros. Example, if I have A equal to matrix of 2, 0, 0, 5. This is what we call the principal diagonal. There are no zeros, but other sides are zeros. So, and the diagonal matrix must be a square matrix. So this is a 2 by 2 diagonal matrix. I can also have a 3 by 3 diagonal matrix. For example, I have B equal to 2, 0, 0, 0, 5, 0, 0, 0, 3. You can see that all the elements in the principal diagonal are non-zero, but elements other sides are all zeros. So this one now is 2 by 2 diagonal. This is 3 by 3 diagonal matrix. Now we have another type of matrix which we call number 6. We call scalar. Scalar matrix. This one is a special type of diagonal matrix in the sense that the principal diagonal elements are the same. For example, I have A to be a matrix of 2, 0, 0, 2, 0. You can see the principal diagonal elements are the same. So this is called scalar. It's a special type of diagonal matrix. So this is 2 by 2. I can also have B to be a matrix of 3, 0, 0, 0, 3, 0, 0, 0, 3. You can see the principal diagonal elements are the same. So you call it a scalar matrix. Now, after this, we have another type of matrix which we call number 7. We'll call it the units. Units or identity. Unit or identity matrix. This is a special type of scalar matrix in the sense that the main diagonal elements are 1 but zeros otherwise. So example, but one thing about this unit matrix is that you denote it with capital letter I. Unlike this one, you can use any alphabet. So in this unit matrix, you have I to be equal to 1, 0, 0, 1. You can see the main diagonal elements are 1, unlike the scalar. Now, since it's 2 by 2, you identify here, this is two identity matrix of order 2. So this is 2 by 2. If it is 3 by 3, you have identity matrix of order 3 equal to 1, 0, 0, 0, 1, 0, 0, 0, 1. You can see this is what makes it unique. The principal diagonal elements are 1. So that is for the types. Okay. That is for the types. We will now be moving to determinant of a matrix.